Question 7.43 says to draw a plausible mechanism for each of the following transformations. So in the first question, I have a tertiary alcohol, and I'm treating that with a strong acid, HBr. So the first thing I should do is draw the Lewis structure of HBr so that I can draw my curved arrows correctly. So the first thing that's going to happen when we treat this tertiary alcohol with a strong acid like HBr is that we're going to convert it into a good leaving group, because hydroxide is not a good leaving group, but after a proton transfer, I'll end up converting it into an oxonium. So I'm just going to draw what that intermediate would look like. So I'll put this over here, and then I'll put OH2 because I have two protons attached to the oxygen now. I still have a lone pair and a positive charge. So now it's been converted into a good leaving group, and I can draw the curved arrow that represents water leaving. So sometimes in the book they'll put minus H2O just to show you that that the water is leaving in this case. It's not necessary to do that, but sometimes it's nice for instructional purposes. So then I can draw my tertiary carbocation that's formed after the loss of the leaving group. And if you notice in the first step that after the protonation of the alcohol with HBr, I would have liberated bromide, and that is going to be the nucleophile in the last step. So the nucleophilic attack is affected by the bromide ion. So I can draw my curved arrow like this, and that gives me the final product. So let me switch pens here, and let's take a look at the last one. So the last one is a dehydration reaction. So it says here concentrated sulfuric acid and heat, but if you remember the leveling effect, which we spoke about in the acids and bases chapter, so concentrated sulfuric acid is a mixture of sulfuric acid and water. So again, based off of the leveling effect, the major species I will have in the major acid species I will have in the solution will be hydronium. So I'll start by drawing hydronium, and the first step is just like in 7.43a is to convert that alcohol, that OH, that hydroxyl, into a good leaving group. So I'm going to draw the oxonium, and so we could draw it if you want to, and draw both, protons like that. That's fine. So now I've converted this into a good leaving group. The leaving group is going to leave like this, and then I'm going to draw my carbocation. And you'll notice that it's a secondary carbocation, and that the carbon skeleton isn't the same as it is in the final product. So that indicates that there must be some kind of rearrangement, and you can see that this is a secondary carbocation, but if I have a methyl shift, it's going to give me a tertiary carbocation. So I move that positive charge over there after the methyl shift. And of course, there's a proton here that I didn't draw, but I'll put it in for instructional purposes. And so the last step is going to be the proton transfer from the water that was formed in this step. So I'm going to draw a water molecule, and that is going to take that proton and produce the double bond. So there we go, and then I get my hydronium back, and this of course gives me my final product, so I could extend my arrow like that. So I hope you find this video helpful about question 7.43, letters A and D.